All right, so it's not bad, or at least it shouldn't be. Much more procedural than the previous one. Uh, like I mentioned before, we're going to find areas contained between particular vectors. Although, oh yeah, it is two dimensions. I'm like, just the angle that it's at, it looked like it was a three-dimensional display. I'm like, that there's a flaw right off the bat. No, it's perfectly fine. All right, no grid. I don't like the grid. It's in the way. Did I turn this on? Yeah. All right, so coordinate 1, 2, coordinate 4, 3, and 0, 0. We're going to create a parallelogram out of this. Normally, to create a vector, I don't actually need to put in 0, 0, but I'm going to create a polygon in a minute, so I want to have it in there. Vector going to A, vector going to B. All right, so then next up, so we have that. Next up is to create the parallel lines and the intersection between those two parallel lines. You could actually use a tool in here. It's pretty easy. If you scroll down and look for one that actually looks like it has parallel lines in it, that'll get the job done because all you have to do is select a point and the line. Right? Select point and parallel line. So point and the line that you want it to be parallel to. All right. Or you just type in what I typed in, but it's going to type it in for you. So either you're doing it or GeoGebra's doing it. It doesn't make a difference. Then I want the intersection. There's an intersection feature there. You can click on it, but you could also just type in intersect. Intersect. F and G. F and G. Oh, there's an intersection of 5, 5. Wonderful. Not that we care, right? I want a parallelogram. Now, in the process of creating the parallelogram, it's going to tell you the area, but it's not going to flat out say the area is this. So I also want you to explicitly request the area, right? So polygon, not in A, B, C, D order, because what it'll do is it'll assume that you want to create a polygon going from A to B to C to D, which is not a polygon. All right, so you need to name the vertices of your polygon in consecutive order. All right, so maybe A, C, B, D, maybe D, A, C, B. It doesn't matter as long as they're in consecutive order. So I went with A, C, D, B. Yes. A, C, D, B, D. I guess I named it differently on my in my handout. Well, it worked there, so either that or I might have typed it wrong here.
Yeah,
Because in the picture it's right, right?
so you create parallelogram A, C, D, D, and align.
Oh, okay, yeah. All right, I'll still take that as a typo because I'm going to forget to change it anyway. So, all right, so you can see here that underneath segment this, segment that, it gives you a number. That number is the length of the segment. All right, underneath polygon, it says 5, but it doesn't tell you what that 5 is. Area of my polygon, which is named Q1. I'm going to make a note of Q1. Now it's explicitly stated in my GeoGebra that it is in fact the area. All right. Now you could do. I never even tried this. I'm sure there's a determinant feature. Yeah, of course there is. I didn't put these in the instructions, but I suppose you can. You can do it this way. Now let's see. Or you can do it by other means. Doesn't matter. 1, 2, 4, 3. don't think I put my matrix in right. Honestly, I don't remember. Is it regular parentheses? No. Honestly, I don't remember how to type in a matrix. So, like, the way I did it the first time, right? Right, but then, oh, okay, gotcha. There we go, good. -5, +5, anything that justifies the absolute value, because remember, the direction of the cross product will give you a positive versus a negative. So, so that explains that. Or I mean, if you want a +5, you can. If you actually want to see a +5, you can put an absolute value. You can change the order. No, you don't need to do that. You can somehow you have to state what the determinant is and show the work for that. So whether you just, I mean, most people are going to be fine, I think, just doing AD minus BC, just using the regular formula. But I mean, this is kind of nice, even though I didn't put it in, because it's one-stop shopping. You got the area, you got the determinant. I look at it, it's like, yes, you got them to match up. It's perfect. All right. And in fact, maybe I'll make that a requirement from here on out. So I'll take that as a typo. Right. GeoGebra, yeah. But also, if there is a follow-up question, what is the relationship, which I just kind of gave you the answer to. So just make sure you state that. Complete steps 1 through 4, but this time use sliders to create general coordinates. All right. So what that would mean is that I would need sliders for each of the entries in A and B. Right. So I can just do that kind of on the fly here. So what people have been doing for assignments that require you to do it particularly and then generally after that is they save it as something, whatever, and then edit what they have in there. So at this point, what I would do is create 4 sliders. Doesn't matter what they're called. I got I, J, K, and L. You could turn them off so that they're not actually on the graph, but they're in your editor. Which I didn't do, so let me do that. And then just make the entries of A and B, I, J, K, and L. All right. It'll look completely wrong when you do this. Because you're like, yeah, it's a straight line. That doesn't make any sense. But that's because the default settings for any value that you type in is 1. So that would make sense there. But now when I start playing around with the sliders, you can see I'm still getting a parallelogram, which is necessary, otherwise I haven't done it right. And then you can draw completely, because everything else is based off of these coordinates. So you have your polygon, you have your areas, you have your determinant, which you'll have to manipulate. You'll put it in as I, J, K, and L, but that's something for you to play around with, right? So that is part 1.